Hi everyone, and welcome to the 25th video in the Weather Unlocked video series. In this video, we'll take a look at what microbursts are, how they form, and the damage that they can cause. So what is a microburst? A microburst is a subdivision of what's known as a downburst, which consists of strong winds produced by a downdraft of the thunderstorm. And these are a localized column of sinking air within the thunderstorm and are usually only about 2.5 miles in diameter or less and are very short-lived, lasting only about 2 to 5 minutes. Hence why they're called a microburst. Now there are two types of microbursts, a wet microburst and a dry microburst. And the names pretty much give away what each of these are, but a wet microburst has an abundance of significant precipitation, while a dry microburst occurs with little to no precipitation reaching the ground. And the image and GIF on the bottom right of this slide show just what a wet microburst looks like when it occurs. So what causes microbursts and how do they develop? So if you watched one of the previous Weather Unlocked videos on hail, you've seen a similar diagram to the one on this slide. Now the red arrows show the updraft within the thunderstorm, lifting and suspending water droplets and hail within the thunderstorm. Now depending on how strong that updraft is, those droplets can be pushed all the way up towards the top of the thunderstorm. However, as the updraft begins to weaken by evaporational cooling or sinking air, that updraft won't be able to hold those raindrops and hailstones up in the thunderstorm any longer. And that's when the downdraft occurs as that core begins to plummet to the ground, causing a downburst and in turn a microburst. Now when a microburst occurs, once it hits the ground, it begins to spread in all directions. And you can see that top image depicting what that might look like as it reaches the ground. And then the highest winds and greatest damage are going to be located where that microburst initially hits the ground before spreading out in all directions. So how can we forecast microbursts? Well, if you watched a previous Weather Unlocked video on skew-T soundings, you'll recognize this upper air sounding, which helps us understand what's going on in the atmosphere and can help us determine what type of weather to potentially expect. So as we're forecasting for the potential of microbursts, some parameters that we look for are instability in the atmosphere, low-level moisture, dry mid-level air, and strong winds aloft. And if we notice that these four parameters are present, along with some other parameters, then we can get a pretty good idea that microbursts will at least be possible within the thunderstorm. Now, when a microburst is occurring, we can interpret the radar data and see the microburst signatures, especially on the velocity product. And a couple previous Weather Unlocked videos on radar fundamentals explain how you can interpret and understand radar products better. So when a potential microburst is occurring, we can look for converging air or air coming together, especially in the mid-levels. And then at the surface, we can see diverging air or air pushing in opposite directions as it spreads in all directions. And you can see the velocity at the surface shown on the right side of this image, which shows those bright green colors depicting winds blowing towards the radar, and those bright red colors showing winds blowing away from the radar. And you can see how those winds are diverging or blowing away from each other. Now, unfortunately, microbursts can be hard to detect ahead of time since they're so short-lived, which can lead to shorter lead times on severe thunderstorm warnings. So it's important to immediately take shelter if a severe thunderstorm warning is issued for your area. Now, these two images show just how destructive microbursts can be. In fact, straight-line winds can reach over 100 miles per hour, producing damage equivalent to an EF1 tornado. And you can see in these images that significant damage can occur to structured homes and trees when strong straight-line winds occur. And on the aviation side of things, microbursts can also be extremely hazardous for pilots. In this far-right image, you can see that an aircraft is descending into an airport following what's known as a glide slope. Now, as this plane enters the microburst, the plane encounters what's known as headwind, or an increase in wind speeds over the aircraft. Now, with these stronger winds, the planes begin to rise above that glide slope, leading to the pilot having to lower the throttle in order to decrease the plane's speed to allow it to continue descending. Now, as the plane flies through the other side of the microburst, the wind direction shifts and is now a tailwind as it's from behind the aircraft. Now, this decreases the wind over the wing, which reduces lift, leading to the plane sinking below the glide slope. However, with the strong tailwind, even the pilot applying full throttle, trying to increase lift again, there may be little, if any, room to recover from the rapid descent, causing the plane to crash short of the runway. Now, thankfully, pilots are now trained to recognize microbursts and take appropriate actions to prevent accidents. However, microbursts can cause significant damage not only to aircrafts, but also to lives and property. So it's extremely important that if a severe thunderstorm warning is issued, you're taking it seriously and immediately seeking appropriate shelter to stay safe. So that concludes this video on microbursts, so make sure to stay tuned for future videos in the Weather Unlocked video series.